Seems to be a little hold up with my house build until April apparently, so we might as well do another little deep dive in the meantime.
The truth is in the phone. The phone doesn't lie.
Interesting you should mention that, Mr Lally, because we were thinking the same thing. We were thinking the data doesn't lie, people lie. They also tamper with the data to make it look like the data's telling the truth, when it ain't. So let's start with Richard Green's January 2023 motion in support of production of grey key supplemental files. In paragraph 3 he explains he's aware that the data from the cell phone devices can be forensically acquired and saved into what is commonly called an image file. This data is then processed by forensic tools which frames it into human readable format. This process can also categorize the data, recover deleted data, and allow for examination of the underlying file system. I have reviewed the image file. This number in the beginning of the image file is actually the hash value that's associated with the file. I'll show you that in a minute. I reviewed the image file purportedly taken of an Apple iPhone 11, which we all know is Jen's phone. The file name and structure are consistent with an image created with the grey key forensic software. Missing from the data are certain supplemental files that are needed to validate the image. When we validate an image, what does that mean? I'll show you that in a minute as well. Specifically, the log file, which includes the hash value of the image, and a plist file that includes decryption information, or the algorithm that decrypts the file. Both of these files would start with the same prefix. And so to complete my analysis, I request that the grey key supplemental files be provided. So what we do know is from this that in January last year, the defence didn't have what they deemed to be a validated image of Jen's iPhone. And this has caused quite the conundrum, because it was in fact Mr Green who discovered Jen's Google search, "House long to die in the cold," at 2:27 AM. Interestingly, he discovered it within these files that Trooper Proctor instructed Trooper Keefe to, let's say for lack of a better term, tamper with. And how do we know it was tampered with? That's the whole idea of this video. So let's start from the beginning with the grey key software. This is the first piece of software that Trooper Keefe used to extract Jen's cell phone data. I'm going to try not to get too technical so I don't lose anybody, but here's how that operation should look.
Let's start by adding our case information for creating a new case in Magnet Automate. We'll be using a test image today for validation. I'll select a default examiner for this test. Next, we'll select what type of workflow we want to automate to run on today's grey key image. These workflows have been pre-built, so I can just quickly select General Mobile with a report being generated at the end for this review. I'm going to let Automate kick off the processing on the first available node, and next I'll add the path to the grey key image we're processing today. Now that Automate has validated the image and correctly identified it as an iOS device, I'm going to select the box under Keychain so that during processing, Automate will use the password and decryption keys to decrypt application data. I'll simply point Automate to the keychain now.
This is the hash keys and the decryption algorithm, and together they verify that the data is the original data extracted with grey key.
Next, I'll add a new evidence number in for all this. Now I need to designate where my outputs for this case will reside. So I'm simply copying and pasting the path from my File Explorer into Automate. And that's all we need to do. Next, I'll hit the Add Evidence Source button and create the case. Our new case is now kicked off. As you can see, the image is being copied to the local node for fast processing.
Now, from this point, you could potentially unpack that zip file remove some potentially incriminating evidence, for example, and then repack the zip file as if nothing had been tampered with at all. Sounds simple enough, right? Except for one thing. The hash key and the algorithm will no longer match. Let me show you a really simple example. Let's just say you have, for example, a picture of a koala. You can have a look at the MD5 checksum for that picture, which is a type of hash, and you'll see that the MD5 sum, or the hash key, is this big long number at the front here. Now, let's go and change something in that file, just something really, really small and insignificant, and see what happens to the hash value. So here we're just going to zoom right in and change one single pixel in the file. And it's not even going to be a visible change. Completely human undetectable change for changing this one pixel. As you can see, it's not visible, the change that was made. Save the file and then go and look at the checksum value, or the hash value. You can see the size is the same and all the other information is the same. However, the hash value is now completely different. And so that's how you can verify a file. So maybe you might write your will, for example, and you don't want anybody to change that will after you die. So you send off that file to your lawyer and you give them the hash key for it, and then when it comes time to reading your will, they can match that hash key and say, well, this is the original file. If anything is changed in that file, then the hash key won't match. And so this is the same thing with a zip file. If anything in that zip file was changed at all, even the zip file itself was unpacked and repacked, it will no longer match that key. Notably, Richard Green says in his motion that the log file, which includes the hash value of the image, and the plist file, which is the algorithm to decrypt the file, are both missing. Not that they've changed, but they've been removed altogether and were never sent. This is a forensic image. It needs to have all its data intact. It's part of the chain of custody that should accompany all evidence. And as Richard Green rightly notes, without it, he can't verify that that's the actual image that was taken from Jen McCabe's phone. If that image file had been provided correctly, complete with its hash and algorithm all intact, this is how it would be forensically unpacked at the other end by the defense.
This week I want to make sure to show you how to properly ingest gray key extractions. I'm going to choose File, Open Case, and then Add, and then you'll see Full File System Gray Key. So if you had a full file system extraction as well, that you had a checkra image, you would load it this way. Here I'm going to choose Zip Archive, and I want to navigate out to my gray key extraction. And the first thing I'm going to do is point it to my zip file and select Open. Now the next thing I want to do is point it to the keychain. So I'm going to go back out to my extraction, same thing, gray key, and I want to make sure I point it to the keychain plist. So you want both your zip and the keychain in order to properly parse and extract more information.
As you can see here, the Cellbrite software takes the plist file, which contains the hash key algorithm, and uses that to verify that this is the original image. I understand the Cellbrite software can unpack the zip file without verifying it. But that would be the same as going into the evidence locker and pulling out a box or an envelope with a broken seal. Is that going to fly with a jury? Probably not. Anyway, moving along. The final tool that law enforcement might use is mapping software, and the most common one used by law enforcement is CellHawk. There's actually a number of different ones, but the point being, These types of tools are usually online because they connect up to a network of satellites and whatnot to map out GPS coordinates.
Hi, I'm Mike Melson, president and founder of Hawk Analytics. We're the company that makes CellHawk, software that lets detectives and analysts rapidly get answers out of cell phone call detail records. Agencies using our software are telling us that they're saving substantial time during their investigations while also solving more cases. So let's go ahead and take a look at how they're doing this. This is CellHawk. It's a web-based application.
As you heard him say, CellHawk is a web-based application. But this poses a problem if you're trying to hide data, because once you've uploaded it, there's a copy of it on a server somewhere. In this case, on CellHawk Analytics server. And not just anybody can access the server. You literally need law enforcement credentials to be able to log in. And once you're logged in, it creates a digital footprint that connects your login to that data. So you see the problem here. Any data that's missing from the data they've handed over to the defense is going to show up here on this CellHawk server. So instead of saving time and doing this operation on the CellHawk server, what did the police investigators do? They cherry-picked GPS data from John's phone and then manually measured out their desired scenario. Had they used CellHawk, they wouldn't have been able to optionally drop GPS waypoints that were inconvenient to their desired scenario. Is a jury gonna buy it? I don't think so. What I can say with absolute certainty is the hash log and the plist file didn't just drop off the image by itself. It was physically removed deliberately. At the end of the day, what they've done is they've ripped the seal off of the evidence folder and handed it over to the defense and expected them not to notice. What they weren't expecting is for Richard Green to find a database entry for the deleted file, including all the data associated with that deleted file. And then on top of all of that, they've introduced human error where it didn't need to be by using a measuring stick to plot Officer John O'Keefe's last movements. There's a lot more holes that can be poked in just this small part of the story. So let me hand it over to Olivia.
Based on the state's theory that they put forth, they say that based on John's phone data, his GPS data, which they're using to tell what time John O'Keefe was allegedly killed, right. They say that John O'Keefe was killed within 56 seconds of the moment that Karen and him arrive at 34 Fairview. So here's the problem with their theory also, just to go off of that. If you look at the state's GPS data report, right. They filed it in their Supreme Judicial Court opposition. Which there's so many problems with their GPS data. That's the thing, is it's not even fair to call it GPS data because that sounds far more credible and reliable than what they've put forward here. They didn't even use a forensic tool to parse through the raw data from John O'Keefe's phone, and they left out several other data sources like his cell site records and all of the other native location data from his phone. They only looked at the Waze location data. But what they've said from that data, which they didn't forensically analyze, which is curious because the Massachusetts State Police uses CellHawk all the time in criminal investigations, just not this one. They didn't want to use the forensic tool 15 months after the fact when they decided to conduct this GPS analysis. And based off of their analysis, they say that John O'Keefe's cell phone stops in between 34 and 32 Fairview Road in the area of the flagpole and fire hydrant at 12:24:40 a.m. The final plotted point was at 12:25:36 a.m. when they say the phone stops showing movement. So from 12:24:40 to 12:25:36, that's 56, right? Yeah, that's 56 seconds. Right. So
less than a minute.
Going off of your theory, I mean, that is immediate. That would mean John is immediately ambushed and attacked.
Right.
But that also completely disproves the state's entire case, because they're claiming John O'Keefe is struck and killed at 12:25, 36 a.m., 56 seconds within Karen and John's arrival at the house. Well, that's problematic, because guess what? Ryan Nagel and his friends in their F-150 arrive at the same time right after Karen and John arrive, and are there for at least over 5 minutes.
5 minutes, right.
So if John is struck and killed by Karen Reed, who they're alleging is, pulling up and then at great speed reversing into and striking her boyfriend within 56 seconds of their arrival, not only would Ryan Nagel and his two friends see this, and the window watchers inside of the house would presumably see this, but also Karen Reed's car would probably strike Ryan Nagel and his friend's car, because Ryan Nagel says in his interview that they parked their car at the end of the driveway at 34 Fairview, and they were waiting there. So Karen's car is parked up by like the fire hydrant,
right.
like near where John's body is later found.
Of course, yeah.
But for her to reverse back 62 feet, which is what the state alleges, right? I actually looked on Google Maps and I plotted this. She would have struck and plowed into Ryan Nagel and his friend's F-150. So not only would they have seen it,
right,
but their car would have been crashed into.
So
nothing about their theory,
right. Based on the electronic,
works.
Based on electronic data,
based on their own data.
Right, exactly.